Let's explore what quadratic functions look like. A quadratic function means that the equation is degree 2, meaning the largest exponent that you see on a variable is 2. So your basic parent function of a quadratic function looks like this: x squared, y equals x squared. As you can see, it's a U shape, and this shape is called a parabola. Now, the parabola has a lot of different parts to it, some different vocabulary. So we're going to talk about the different vocab that has to do with parabolas. A parabola has one point where it changes direction. So as you can see from left to right, that's how we read graphs. From left to right, we're going down. It's decreasing from left to right. And then all of a sudden we get to a point where it changes direction. Now we're going up from left to right. And so this point right here is called the vertex. So for the parent function, the vertex is at 0, 0. When your vertex is at the lowest possible point on your function, it's called the minimum value. And our function is opening up because everything is going toward positive infinity for the range. Remember, range is all the y values on your function. And so if we were to write the range of this function, we would go to the lowest point. So the lowest our y values go is 0, and then everything greater than 0. So we would write y is greater than or equal to 0 for the range. The domain of this function is everything from negative infinity to positive infinity, because if we look at this, if we zoom way out, it's going to take forever, but eventually this is going to get wider and wider and wider, and every x value in the negatives and every x value in the positives is going to be covered in the domain. You can also think of it this way. If we were to plug in values for x squared over here, there's no value that would be undefined. So our domain would be negative infinity to positive infinity. The next thing we're going to talk about is the axis of symmetry. The axis of symmetry cuts your graph perfectly in half, and so it'll be symmetric about that line. And the line is x equals 0. You can see that it goes right through the vertex at 0. And we say x equals 0 because it's the equation of this vertical line. See how every point is equidistant on each side to the axis of symmetry. Now, let's think about the intercepts. The intercepts, we only have one intercept. It's both the x and y intercept on this graph, and it's 0, 0. But let's look at some other types of graphs next with parabolas. So let's see, what about this one? Yeah, this is a good one. You can see that it's also opening up. So compared to the parent function, see there's the parent function, it's also opening up and pointing toward positive infinity for the range. And it also has a minimum, but this time it's shifted. It's shifted to the right and it shifted down. So now our minimum value is at the range of -2. Our vertex is at 1, -2. So that's our lowest point. Remember, the vertex is where your graph changes directions. It opens up, and this time we have 2 intercepts. We have 1 y-intercept. We're always going to just have 1 y-intercept for parabolas, but sometimes we can have up to 2 x-intercepts. The x-intercepts are also called the solutions of the function or the zeros. So you'll see those different words used throughout this unit, and you need to know that they're all the x-intercepts. So we have 2 solutions or 2 zeros, and they're at 0 and 2, or as ordered pairs 0, 0, and 2, 0. So this one has 2 solutions, and the parent function has 1 solution. The axis of symmetry, remember, it goes through the vertex, and that's an equation x equals. So look at our x value. Our x value is 1, and so the equation x equals 1 is our axis of symmetry. Let's look at another one, but this time we want to look at one that's facing down or pointing down. So remember, this one had a minimum value, so it was the lowest it went. And now here's an example of one with a maximum value. So the U is upside down, it reflected, and we have our vertex at a maximum. This vertex is at 3, 4, 3, 4, and we have 2 solutions, and remember the other names are x-intercepts and zeros. So solutions, x-intercepts, and zeros. And we have 2 at 1 and 5. Our y-intercept is way down here at -5. And the other piece of vocabulary is our axis of symmetry. And remember, it goes straight through the vertex and cuts it in half. And it's an equation. X equals 3 is our axis of symmetry. So maximum point, our parabola opens down, vertex, zeros. Those are the vocabulary words for that graph. And then lastly, let's look at another one that doesn't have any zeros. Here's an example. It does not have any solutions. So in fact, if you were to solve this equation, x squared plus 4 equals 0, it would have imaginary solutions, no real solutions. So that's why it's not touching the x-axis at all. So if it asked you what the zeros were or what the solutions were, you would say no real solutions. The vertex is at 0, 4, and that means the axis of symmetry is actually the y-axis. So remember, that's just x equals 0. And that is the vocabulary that you need to know around parabolas.